All right, guys, welcome to Lesson 9. We're talking about volumes of revolution. We're still talking about finding volumes of solid shapes. So it's a lot like the one that we did before with volumes of known cross-sections, and actually it's just kind of a difference in the way that the question is asked, but really the process we're going to go through and the concept is pretty much the same. So let's take a look. So let's suppose that I have this function here, which is just the square root of x. I've got it graphed over here. And the distance from the curve to the y, or let's say to the x-axis in this case, that's just the y value, right? And the y value is the square root of x in this case. So just to kind of keep things simple, no matter where I pick along this curve, like let's say right here, that length is the square root of x. Whatever the x value is, take the square root of it, and that's the height. Or here's another one. That's also the square root of x. Whatever the x value is there, the square root of it, that's the height. Okay, so let's keep that in mind. Now we're going to do something that we did before, and we're going to take this two-dimensional image into a three-dimensional viewing. So I'm going to take it and I'm going to rotate it here. And now we're looking at a three-dimensional graph, right? Now, this length right here, which I told you was the square root of x, right? I want to pretend that that is the radius of a circle. Okay? Let me trace my shape here, because as soon as I do this, it's going to go away. So I need to trace it so it doesn't go away. So I'm going to put my curve there. Now, let's let that length right there be the radius of a circle. Now I'm going to say right about there, we're looking at. Now what I want to do is I want to rotate around the x-axis to create a circle. So watch what I do here. I'm rotating around the x-axis to create a circle. Now, what is the area of that circle? The area of that circle is pi r squared, right? And we've already talked about what's the radius of that circle. It's the square root of x. So the area of that little circle right there is pi r squared. Now we could do that a bunch of times, right? Let me go ahead and trace this one real quick, and I'll show you another one. Okay, so now let's say I draw a radius like right here. That's also the square root of x. It's a different x value, so you get a different radius, right? And let's go ahead and we'll put another circle right there. And in fact, we can just kind of keep doing that, couldn't we? We can keep putting circles everywhere along this thing. And if we did that an infinite number of times and added them all up, we're going to end up with a cone, aren't we? Now, how do we add up an infinite number of these things? Well, we would take one of these little area slices called a disk, and we would integrate it from our first point, which is 0, to our last point, which was about 4. Can't really see it right now. And there you have it. And now I've found a way to find the volume of what we call a solid of revolution. Okay? It's basically formed by revolving a radius around the x-axis. But basically, it's the same idea. We're still putting shapes on top of each other and integrating to put them all together. Okay? And so we create what's called a volume of revolution. And there you guys have it. So you end up with like this interesting looking little cone shape. Okay? And so that's the idea. And so we're going to be going through, and you guys could use this website, by the way, if you just want to copy this address up here. And you could do this. You could type in the functions that you want to work with, put the intervals that you're interested in, and you'll have to mess with a couple of settings. But also another thing I found that on this website, you have to go down here at the bottom and say OK. Otherwise, you won't be able to make any changes up here. But by the way, it also has the thing we learned about for the past two classes, cross-section problems. So it has that too. So you guys can do this and visualize all the shapes that we're making. Kind of a nice little website. Anyway, that's the idea. So let's go back to our notes right here. This is something you're going to want to write down. This is the steps that we're going to go through. So I might want to pause the video here and write these down, and then we'll go ahead and we'll get started on some example problems. All right, so for our first example here, let's go ahead and take a look at our instructions here. It says, for each problem, find the volume of the solid that results when the region enclosed by the curves is revolved about the x-axis. So they've shaded this area, and so what would it look like if you spun that around the x-axis? Right? Now, let's kind of analyze the different parts of what they're presenting to us here, because there's a lot of parts that they're giving us here. First of all, notice this little spiral over here. That's telling you what you're rotating this blue shaded area around. So we're rotating that blue shaded area around the x-axis to create a cone-like shape, right? The next thing you can see up here is you've got a couple of equations, and you want to know what they all mean, okay? This first one here is the actual function that we care about right now. It's x squared plus 1, okay? But they do give us two other equations here. They give us y equals 0. That's actually just the x-axis. And they give us also x equals 0. And that's just the y-axis. And then finally they give us x equals 2. And that's this line right here. So why are they giving us so many lines? Well, basically those are all of our boundary lines that we're staying in between. So they want you to find this area, this blue shaded region, which is locked between this line, and this line, which are these three things here. And then finally, the actual function that we're looking at, which is that. So we're looking at the area that's enclosed by those 4 lines, basically. Okay? And so let's go ahead and get started here. So I think I'm going to go back to this GeoGebra website here and try to use this so that you guys can see the picture as you go. Now, first of all, we want to find our radius. That's step 1. What is your radius? And as it's said in the steps that you guys copied down, your radius is going to be whatever the function they give you is minus the axis. Okay? Now, technically, whichever one's on top should come first. Okay? So now, here's my function. It's this curved line here. And here's my axis, because I want to revolve it around the x-axis, right? Now, since the function is above the axis, it's f minus axis, right? But sometimes your axis could actually be up here. We'll talk about those later, but you can rotate them around axes which are above the curve, in which case, if you do that, then it should be axis minus f, because you always do top minus bottom when you're integrating with respect to x. But to avoid the whole issue, we can always, as you guys already know, just slap some absolute value bars on it. It doesn't really even matter. Now, in this case, my axis is the x-axis, which is the line y equals 0. So when you're rotating it around the x-axis, it's 0, and so really, there's your radius, okay? So anytime you're rotating it around an axis, since the axis, anytime you're rotating it around an x-axis or the y-axis, then it's just 0, and therefore your radius will be your function. All right, and so now we're going to go ahead and move on to step 2. Now, step 2 is this. Now, we could just do this mindlessly, and it's going to just be the area of a circle is pi r squared, and this is my radius, so it's just going to be f of x squared. And by the way, the absolute value bars are kind of unnecessary. I'm just including them for good practice, but you don't actually need them in this case because the axis isn't even there. All right, but I don't want to do this mindlessly. I want you guys to see what we're doing here. So let's take a look at it. Oops, I didn't want to erase that much. I'm going to erase all this stuff here, and then I'm going to rotate this shape here so that we are looking at it in a 3-dimensional setting. Okay? Now, whenever we do this, we are creating when I rotate this around the x-axis, I'm creating a circle. And so what we're finding here is I'm finding the area of a circle with a radius that's equal to the height of my function, right? Now, the third step is I want to find an infinite number of these little circles from beginning to end and add them together. My beginning point was back here at x equals 0, and my ending point was up here at x equals 2. And so if I add together an infinite number of little area disks of circles there, we get a volume. And that volume would be this shape here, if I can manipulate things appropriately. There we go. Gone too far here. And this is the image that's created whenever you do that revolution. So I just found the volume of this weird looking little, I don't know, looks like a hat of some kind, I don't know, a bell, a horn tip. But what we will have if we actually do this integration is we will have the volume of that shape there. Now, in the case of the problem that we're actually working on, let's go ahead and go back to that. That is the equation x squared plus 1. So I'm going to be replacing this f of x here with x squared plus 1. And all I have to do is put that in my calculator, and I've got my answer. And this is the result that I get for number 1. All right. So step 1, identify your radius. And in this case, our radius is just the function that they give us. Step 2, set it up as an area formula, pi times that function squared. And whether or not you include the absolute value lines right now doesn't matter. You can if you want to, but it's not necessary. Third, integrate that area formula from your beginning point to your ending point, and that will give you the volume of the solid that is created by rotating that image around the x-axis. So let's go ahead and throw one of those at you. I'm going to have you guys do number 1 here. You don't have to go on that GeoGebra website. You don't have to go there and visualize it if you don't want to. You could probably even start seeing it in your head now if you wanted to. But it doesn't matter. Just go ahead and work this out, and when you unpause the video, I will have the solution. This is number 1 on your homework sheet, so make sure you're doing this on your homework and not on your notes, okay? All right, and so here's our answer. Our function is the square root of x. Its distance from our axis, which is this line here, is just the y value of that function, which is the square root of x, so that's my function. And the area of the circle of revolution would be pi r squared. And if we integrate from 0 to 1, you'll end up with that little shape. And if you want to see a 3D view of it, it would probably look a little something like a bowl, if you will, like a little tiny bowl, if you were to rotate it around the x-axis. Okay? And that's it. Let's move on to our next one. And so in this example here, we're showing you that you don't always have to revolve it around the x-axis. You could revolve it around another horizontal axis. In this case, we're going to revolve it around this line right here, which is the line x, I'm sorry, not x, it's y equals 1. Okay? So I want to revolve it around that line there. And so they specify that right up here that we're revolving it around the line y equals 1. That's my axis of rotation. And once again, they're going to go ahead and give us, all the boundary lines. So first of all, we have our primary function here, which is this guy, represented by this curve right here. And then we have the line y equals 1, which is our axis, but it also serves as a boundary line for the shaded area. And then finally, we have the x equals 4, which is basically just telling us this is as far as we're going to go. And putting all 3 of those together, you guys can see that we're looking at this shaded region right there. Okay, so that's what all the information breaks down into meaning. Now, I want to rotate this shaded region around this axis of y equals 1. So how do I do that? Well, really it's just the same way. Step 1 is to find your radius. And as I told you before, your radius is the absolute value of your function minus the axis. Okay? Now in this case, my function is this guy right here minus my axis, which we see is 1. So I'm going to subtract 1 from that. Now, you can leave it like this if you want to, or you could just simplify it. It really doesn't matter how you do it. Now, if you're going to go with the graphing calculator approach, which we obviously are going to do that, maybe it would be better to go ahead and do this instead, just so we're kind of sticking to this standard protocol. But you could do it the other way that I just showed you. But on my calculator, I'm just going to call that y1, and I'm going to call this one y2. My axis, I'm going to call y2. The function itself, I'm going to call y1. And so I'm just going to put it like this in my calculator. Okay. And so there's my radius. And so step 2, I want to rotate this. That's a little bit too big. I want to rotate this around that axis there to create a circle, right? And so I want to find the area of that little circle. And so that's going to be pi times the radius squared, right? And then finally, I want to find a whole bunch of these little circles and add them all up and ultimately create this little bowl shape that we got going on here if we were to rotate that. And the way you do that is by adding all the circles up, starting from 0 to your last point there, which I can't see anymore because I've colored over. It looks like it's 4. And it's pi r squared. Now, just so you guys know, from now on, I'm going to start putting this pi out in the front. It's going to make some of our problems a little bit easier later on, I think, but there you go. So I'm going to put that one out in the front there. You don't have to, but I think it might come in handy later. We'll see. But anyway, from here, I'm just going to go ahead and punch this information in my calculator. I'm going to enter this under y1. I'm going to enter this under y2. Back at my home screen, I'm going to type that in, and we should end up with our final answer, which would come out to be 25.13 with a bar on top of it. All right, and so, well, maybe it's not a bar. It stops at 3. We'll see. But there you guys go. That's that one. So what made this example special? It was the fact that we were not rotating around the x-axis. Instead, we were rotating it around a different horizontal axis. And so when you do that, you have to do, your radius is no longer just the function. It's going to be your function minus the axis, or in other words, y1 minus y2. So I'll let you guys practice one. All right. So here is your problem. Go ahead and set it up and see what you guys get. When you unpause the video, you'll see the solution. Now, unless I made a mistake, you're actually going to end up with the same exact answer, 25.133. Kind of a little bit of a lame question, honestly, but that's how it worked out. It's the same shape. It's just everything's been shifted down. But your radius is y1 minus y2, where y1 is the function and y2 is the axis. And so the area of the circle that would be generated by spinning that around the axis of -2 would be pi r squared, which is this here. And the volume is to integrate that area formula from 0 to 4 to add up the infinite number of little circles you would create to end up with a bowl. And it's, like I said, the same answer. And just so you guys know, well, actually, we'll get to that later. I was going to talk about how the axis can be somewhere else. But for now, let's go ahead and move on to our next question. All right. Well, what we're about ready to do right now is we're going to change our rotation axis from being horizontal to vertical. Now we're going to be rotating this thing vertically around the y-axis instead. Now, here's the thing. Whenever you're rotating around the y-axis, you need to have all of your functions in terms of y, and you're going to integrate with respect to y. So I would encourage you guys to write that little note down somewhere in your notes. So anytime you have a vertical axis that you're rotating around, your functions need to be in terms of y. So that means that it's not going to be y equals something, right? It's going to be x equals something, which we've already got going on here. And also, when you do your integration, we are integrating not from left to right, but from bottom to top. So you want to keep that in mind, okay? So here we go. So first of all, let's find our radius. Now, my radius is going to be my function, which is this guy right here. I'll highlight it. Let me use green. That's this guy. There's my function. And the axis I'm rotating around, which is going to be the y-axis in this case. So that's this line right here. That's what I'm rotating around. And that's this equation right here, 0. So my radius is going to be the function, which I'm not going to call f of x this time. I'm going to call it f of y, because this is a function with respect to y, minus my axis. Okay? And in this case, my function is y cubed, and my axis is 0. And like I said before, same thing when you're rotating around the x-axis. Well, if you're rotating around the y-axis, it's just 0, so you really don't even need it. So you could really just leave it as the function itself. Okay? Now, let's move on to the area step. Once again, we're rotating this. So I'm rotating it horizontally, so that's going to look like this. Okay, we're not rotating it this way like we were before. We're rotating it around the y-axis. Right? And so we have pi. The radius is just going to be the function itself squared. Okay, that's my area of a circle that I would get by rotating around the y-axis there. And then finally, if I want to find the volume, which would come by adding all those little circles together, you're going to end up like this little cone as a result if you do that. You would have to integrate. Now remember, we're doing this with respect to y. And that's significant because when you're integrating with respect to y, you have to remember that we integrate from bottom to top. So my starting point is down here at 0, and my ending point is up here at 1. So we're integrating from 0 to 1. All right? And once again, at this point, we're going to put in our calculator. Now, you got to remember, your calculator only does integration with respect to x. So when we type it into our calculator, it's going to look more like this. Where we have defined y1 as x cubed instead of y cubed. Because your calculator is not going to do things in terms of y. It just doesn't do that. But it doesn't matter. So on our calculator, we're going to enter x cubed under the y1 slot, and that really represents y cubed. And then when we go to our home screen, this is what we'll type in our home screen to get our answer. Okay, so we just kind of have to pretend we're integrating with respect to x whenever we put it into our calculator. It would be a different shape, but it would have the same size, and therefore it's going to have the same volume, so it's okay. So if you want to watch me do it, just in case, you're going to go to y equals, and instead of putting y cubed under the y1 spot, we're going to put x cubed. Then we're going to go back to our home screen. We're going to put our pi symbol there first, and then we're going to put our integral symbol next. And we're going from 0 to 1. We're going to put our absolute value on there, not because we really need to, because there's only one function anyway, but we're going to do it anyway just because we want to keep the habit alive. All right, put y1 in there, which is our function x cubed, and put dx, enter, and you got your answer there. 0.785 is the approximate volume of that little strange horn-looking shape that we got by rotating. All right, so that's it. So you're really not doing a whole lot different. The only thing that's really different is you're visualizing it differently. So you're rotating it around the y-axis, and you have to remember you're doing things with respect to y, so that means when you do your integral, you're going bottom to top rather than left to right. So let's go ahead and throw one of these at y'all. All right, so I don't think that's the one I wanted. Just a second. All right, and so here's the one that I'm going to have you guys do. like you guys to go ahead and find the volume of the shape that would result if you were to rotate this blue shaded region around the y-axis. Pause the video here, and when you're done, you will unpause it and you can see the solution. And there you guys go. Radius is just the function itself, since we're rotating around a y-axis, which the function is 1 over y. We don't really need the absolute value bars because it's just one function. We only have those on there when we're subtracting, and we just want to be careful that we didn't make a mistake and put the wrong one first. But in this case, it doesn't matter. Step 2 is the area formula. So that's pi r squared. So if my radius is absolute value of 1 over y, then my area is pi of the absolute value of 1 over y squared. And then finally, to get the volume of the shape that result from the rotation, we are going to integrate from the first point to the last point, which might have surprised you there, but we're starting right here. It's not 0, it kind of looks like it, but they tell you up here in the instructions that it starts at that blue line right there, which is 1/6, and it ends at 2. So it doesn't start at 0, it starts at 1/6, and it ends at 2. And so if you didn't get the right answer, that might have been why, but that is the answer there. So you do have to pay attention to those little details at the top. All right, let's go ahead and take a look at another problem. Same thing. So, you might recall we started off with a basic example today, and then we talked about how you could have a different kind of axis. Then we moved into the y-axis, and now we're going to show you how you can have a different vertical axis. But it's still vertical. So notice that in this case, I'm rotating around this vertical axis right here. That's not the y-axis. The y-axis is right here. So I'm not rotating around the y-axis this time, but I am still going to be rotating around a vertical axis. And so the same principle applies. Our functions need to be in terms of y, and we have to remember that we're integrating with respect to y anytime we're rotating around a vertical axis. And so let's go ahead and get our area, or our volume, I should say. Step 1 is we want our radius. My function here is that guy represented by this curve, as you guys can see. And the axis that I'm rotating around, it tells you right here, is x equals -1. And that's this line right here. And since we're rotating vertically, my radius is a horizontal radius, like that. So when I rotate it, it goes like that. So we have a circle going horizontally, which means that the radius is going to be horizontal. So when you rotate around a vertical axis, you get a horizontal circle, and therefore a horizontal radius. And so my radius of that circle there is the distance from my function to the axis, which once again, you can find that by just taking your function, this time in terms of y, and subtracting from it the axis, which is -1. Okay? And then you just take the absolute value of that. And once again, taking the absolute value is not necessary if you actually know which one should come first. Which one should come first? And if I chose not to use absolute value, which one of these should come first? Would it be the f of y or the -1? And how do you know? Well, it would be the f of y. Why is that? Because it's farther to the right. The f of y is farther to the right than the axis. If I had the axis over here, then technically the axis would have to come first, and that can happen. But in this case, that's not what we're doing. So since the function is farther to the right, then that one comes first in a subtraction problem. But to avoid error, I just always encourage people to go ahead and throw the absolute value because we're doing it on the calculator anyway, and it just makes life a little bit easier. So there's my radius. Now I want to find the area. Pi radius squared. Volume, integral of your area, pi radius squared, with respect to y, and therefore we integrate from bottom to top. So down here, that's at the line y equals -1 up to here. So we're integrating upwards here from -1 to 0. And once again, you're just going to go ahead and punch that into your graphing calculator. And what you would get is Let me shrink everything up here so I can see the answer a little bit better. There we go. 1.676 is the answer. And now that I'm looking at their answer, I see that I kind of got a little bit rushed on that one because I didn't take the time to actually fill in what f of y was. F of y is negative y squared, right? So that's why they have that there instead of f of y. But same stuff, though. Same stuff. So that's it. All right, so we'll let you guys go ahead and try one of these where we're rotating around a vertical axis that's not the y-axis. So go ahead and try this problem here. Pause the video. When you unpause it, you'll see the solution. All right, so I'll let you guys look at that. You just, for your radius, it's your function minus the axis of rotation, which is -1. If that just simplifies, though, to this, right? So that's my radius, and therefore if we plug it into our area formula for a circle, because we are rotating this around the axis of x equals -1 there, we get a circle with an area of pi with the absolute value of y squared. And then if we wanted to create the cone by finding the infinite number of little circles and adding them all together, we would integrate from 0 to 2. And we're doing that with respect to y because this, once again, this is a vertical axis, rotating from bottom to top, and you get this. Now, another way, a little bit more like the one I did on example 2 today, would be to, I like this way more, that's why I chose to go this way. But another way is we could have just defined this on my calculator as y1 equals x squared minus 1, right? And I could have defined this as y2 on my calculator, right? Oh, oops. And then, therefore, my radius would be y1 minus y2. Now, as soon as you do that, though, you're pretending that you're doing this with respect to x, but that's okay. And so then your area would look like this. And your integral would look like this. And we would have an x here on our calculator, even though we really are doing it with respect to y. But this is just for the calculator, okay? The benefit of doing this is that technically you guys really could do this integral by hand because we don't need the absolute value bars on this one because we know which one should come first, and we've already figured that out. So it's y squared, and you end up with just what we have there, y squared. You guys can integrate this, right? You could use the first fundamental theorem of calculus on this, and whatever you get when you're done, just multiply it by pi, you'll have the answer. So you guys really could do these without a calculator. The absolute value bars, if you don't want to use them if you're doing it by hand. So if you're going to do it by hand, you really do need to know which one comes first. Then you don't use the absolute value bars. Then you just simplify it and do it by hand in the way you normally would. But we are going about things with calculators in this lesson. So, but if you feel up to it, give it a try. Try doing it by hand just to see how you do with it. The reason I focus on calculators here is because on your AP exam, these questions are almost always calculator-based questions. But not always, but almost always. So I'm going to call this a mismatch question. It's my last example for the day. I'm going to call this a mismatch question. Why is it a mismatch? It's a mismatch because my functions are in terms of y. That means that we have x equals something with a y in it, right? But my axis is a horizontal axis. The line y equals -1, that's right here. That's a horizontal axis. And when you have a horizontal axis, you're required to be doing everything with respect to x. Our functions need to be in terms of x. And our integrals need to be with respect to x. Every once in a while in the AP exam, they'll give you one like this, where they're giving you the functions written one way, but the axis requires the functions to be written another way. So my functions are written in terms of y, but since I'm rotating around a horizontal axis, my functions actually need to be in terms of x, and we also need to integrate with respect to x, not with respect to y. So what's the solution? We're going to rewrite the equations by solving for y. We're going to rewrite our equations by solving for y. That's a nice little note to have in your notes. I'd encourage you to have it. But I'm going to delete it now. Okay, so here it is. So we've noticed that we have a mismatch. So what I need to do then is I need to get the y by itself. So here's my first function, and here's my other one. And that one has a negative in the front of it. Okay, so the first thing I'm going to do is I'm going to square both sides on this one to cancel out that radical. Then I'm going to minus the 3 on both sides. And I don't like that negative there, so I'm going to divide everything by a negative. Okay? Same thing with this other equation here. We need to get the y by itself. Now this one has a negative in the front. So the first thing I'm going to do is I'm actually going to divide both sides by a negative, which just basically means I'm going to end up switching the negative to the opposite side there. And then I'm going to square both sides, but you know, when you square both sides, the negative goes away, so you actually just end up with that, which we already have. So believe it or not, this thing is just going to actually turn out to be the same exact equation. And so the reason for that is a little bit complicated, but as you guys know, like what if we worked backwards? What if I were to ask you to get x by itself here? Well, if you did, you would end up with y equals plus and minus the square root of 3, I want to say, yeah, minus x. Okay, you'd end up with that. And remember, the plus means the top half, and the minus means the bottom half, or whatever, or the left and the right halves, I should say. So when you, I think I did that wrong. It was supposed to be x equals this. So if you got the x by itself again, this is what you would have, right? And when you have things in terms of y like this, the plus means the right side. That's the right side. And the minus means the left side, right? But since we went ahead and got the y by itself, we ended up with this. We just ended up with the same equation twice. And the reason for that is because you don't need two equations to represent this shape when you're thinking of it in terms of x. It's just a normal parabola at that point. So, long story short, when you see this kind of a situation and you solve for the variable, you're going to find that you just get the same thing twice, and all that means is you really just have to do one function. Okay, but that's your first step. Okay, aside from that weird thing about having two equations that turn out the same, lay that strange little thought aside for a minute and just know this. What do you do when you have a mismatch? You solve for y, or you solve for x, depending on which one you want. In this case, I wanted to get the y by itself because I need everything to be in terms of x. Okay, so now I've got my new equation. My new equation is y equals negative x squared, and I believe it was plus 3, wasn't it? I believe it was, yes. Okay, so we're not going to use these now. We're going to scribble those out. We don't want that. So now we're ready to find now we're ready to begin the problem. So after this, business as usual. Okay? So once you've fixed the mismatch by solving your equation for the opposite variable, just go ahead and solve it like you normally would and use your new equation instead. So my radius, once again, it's the distance from my function, which I'm going to call now negative x squared plus 3, down to the axis, which is negative 1. So my radius is going to be the function minus the axis. Right? And you could simplify this if you want to. Or you could just stop now and call this y1 on your calculator and this y2 on your calculator. Next, we're going to find our area. The area is going to be pi times the radius squared. And my radius is negative x squared plus 4. And once again, if you're going with the calculator view at this point, you would have on your calculator that. Okay? And then finally for the volume, we're just going to integrate our little area formula with the pi out front. And we're doing this with respect to x, or on your calculator it would look like this. We still need to find our limits though. How far are we going? Well, since I'm integrating with respect to x, remember it's left to right, so we're going from here to here, which is negative 2 to positive 2. So steps are pretty much the same, all right? We would plug that into our calculator one way or another. You could either plug it in as you go, step by step, like I was showing you, or you could just take your ultimately simplified one and plug that into your calculator. But either way, we end up with 107.233. Okay? Now, let's go ahead and give you guys one here. Where was I? All right. So I want to do, that's not the one. This one right here. All right. So I want you guys to notice something. We have a mismatch, but you have to be able to recognize that. So I want you to pause the video here and think for a minute. How can you tell that this is a mismatch? Here's how you could tell it's a mismatch. These functions are in terms of y, but I've got a horizontal axis. That's a mismatch. So what I want you to do right now is I want you to take this equation, pause the video, and I want you to get the y by itself. When you unpause it, you'll see my solution. And there you have it. If x equals the square root of y, we just square both sides, and you end up with x squared equals y. And that's it. All right? Now, the next step is to do business as usual. So pause the video here and see if you guys can, well actually, no, that's good. Pause the video here and see if you guys can identify your radius. When you unpause it, you'll see the solution. All right, so there you go. It's function minus axis, right? So here's my function, here's my axis, function's on top, so it's functions minus axis, and it's just 0 for the axis. Therefore, the radius is simply the function itself, x squared. Pause the video here and show me the area formula, please. There you go. Now, here's the challenge. I want you guys to sketch the circle. Sketch a circle somewhere on that picture on your own, showing me what the circle looks like. That is the area that we just represented there. That area represents some kind of specific circle on there, doesn't it? See if you could sketch a circle. There's really a bunch of different answers, but sketch one. That's important that you guys know how to visualize this. If I'm rotating it this way, that means my circles are going to be going this way vertically. So that's what your circles will look like on this graph. And now I want you guys to go ahead and calculate your volume. So go ahead and pause the video here and see if you guys can calculate your volume. All right, and there you guys go. That's the answer. Let's see, I think that might close us out for the day. For you guys, you have another one like this. It's number 10. It's a mismatch. I want you guys to remember that. You'll have to notice it. It's a mismatch. But see if you can figure out why. I'm not going to count this one as a student practice in the notes here. It's still just let you guys do that one on your own for your homework. But we'll see you guys in class next time, and have a good one.